All right, part 3, and this is the last part, I promise, because we're finally made it to page 4. But in this example here, we're actually going to be going backwards. So in the first, in the second part, we were expanding them to write them as multiple logarithms. And in this part, or in this section of the notes, we are already given multiple logarithms, and we actually want to condense them into one logarithm. Now, why it's important to be able to condense is if you do have to solve a logarithmic equation with multiple logs such as this, then before you can rewrite it into exponential form, you have to condense it first. So that's why we are learning how to condense. We're going backwards. Okay, so the first thing that I see about this problem is that we do have this plus right here at the beginning. And you go basically from left to right. So if the plus comes first, then that needs to go, that needs to be the first thing that you do. So remember, if two logs are being added together, that's actually the same thing as multiply. So this is going to be log base 3 of, and since this x is by itself, I'm going to put it in the front. So it's going to be x times x plus 2. And I'm already done now with this part. So let's look at this second part. It says minus log base 3 of 2. So let's keep in mind what that means. If it says subtract, if it's being subtracted, then that actually means that this is going to be divided by 2. Now, you're done right there. You don't really have to go any further if you don't want to. If you would like, you could distribute that x and, just make it a little cleaner. So it would end up being x squared plus 2x over 2. That would also be fine, but either one of these forms is fine with me. As long as you have as long as you have one log in your final answer, then you've done it correctly. Okay, now this one, we see it has numbers out in front, so that's the power property where you can change them to exponents. So I'm going to do that first before I do the subtraction. So this 2 will become the exponent for the m, and this 3 will become the exponent for the n. Now, don't make that 3 negative. I know you want to make it negative because there's that minus sign in front, but that minus sign indicates that this is already going to be a division problem. So if you make this negative, then technically you'd have to turn that to a positive plus and make it a multiplication problem. But don't do that. The negatives in front do not carry along with your exponents. So this is going to be log a m squared minus log a into the third. Now let's turn this into a division problem. So we're going to have log base a of m squared over n to the third, and that's your final answer. And again, remember at the end you want to be left with one log, not multiple logs. So we don't want 2, we want just 1, with everything else right here like this. Okay, now this one looks fairly complicated, but if you do one step at a time, we should be just fine. Anytime you have these power properties or the numbers out in front, I would recommend doing those first. So this, of course, becomes the exponent for the m. So log base b of m to the 1/2. This becomes the exponent for the 2n. So plus log base b, and I'm going to put this in parentheses because I want to make sure that both the 2 and the n are being raised to 3 over 2. Minus, and this doesn't have any logs, so here's what I'm going to do. I'm actually going to just go ahead and kind of break this up just a little bit. This is m squared, but then I can also break this up. Well, no, I don't have to do any of that actually because it's already being condensed. So actually this just makes this a little bit easier. Since we're trying to condense it, you don't need to expand it any further. That's my bad. Okay, now let's condense the first 2. So if you look at just these first 2, those are additions, so that means we're going to be multiplying. So that's going to end up being log base b of m to the 1/2 times 2n raised to the 3 over 2 minus all this stuff over here. Okay? And then last but not least, let's go ahead and write this as a subtraction problem, or a division problem. So on top, m to the 1/2 times 2n to the 3/2, and all of this is going to be over m squared n.